Dear students, in this lecture, we are going to discuss about average and RMS value of sinusoidal waveform. For a given signal, the maximum value of current is taken as Im. This is Im. For a given signal, the maximum value of current is taken as Im. And the given waveform, first we should check whether it is a symmetric signal or unsymmetric signal. So for sinusoidal signal, it is a symmetric signal. For symmetric signal, average value should be calculated for half cycle only. As we discussed in previous lecture, if it is unsymmetric signal, average value should be calculated for half cycle only. So for given signal is symmetric signal, so that average value should be calculated for half cycle only. So the formula for average value equals to area under the one alternation divided by base length. Area under one alternation. One alternation is nothing but half cycle. Area under one alternation divided by base length. So that we have written average value of current for given signal equals to 1 by T by 2. T by 2 means here this is the total T. Time required to completion of one cycle is nothing but time period. For we are going to calculate average value for half cycle only, so that here time period equals to t by 2. T by 2 is nothing but 0 to pi only. We are going to calculate average value, so that the average value formula will be 1 by t by 2 integral 0 to t by 2 I dt. So here t by 2 is nothing but pi, base length. So I average equals to 1 by pi integral 0 to pi. So I equals to Im sin omega t d omega t. So here constant term Im by pi into integral 0 to pi sin omega t into d omega t. Next, Im by pi into integral sin theta can be written as minus cos theta. Integral sin theta can be written as minus cos theta, so that my Im by pi into minus cos omega t and limits pi and 0 to pi. So Im by pi into this can be written as this minus cos omega t can be written as Im by pi into, we can interchange the limits, cos omega t into pi to 0. So next up in this here we can insert the limits. Im by pi into cos 0 value, cos 0 minus cos pi. So cos 0 value minus cos 0 value 1 plus minus of cos pi value minus 1, minus into minus plus. So it will become 2, 1 plus 1, 2. So 2Im by pi equals to 0.6366 Im. So in this way we can calculate the average value of sinusoidal signal. Next, we are going to discuss about RMS value of sinusoidal signal. RMS value of sinusoidal signal, root mean square. For a given signal, similarly for a given signal, the maximum value of current is taken as Im. Similarly, if it is symmetric signal, RMS value can be calculated for half cycle or full cycle. Both will be same. If it is unsymmetric signal, RMS value should be calculated for entire cycle. So that the given waveform signal is symmetric signal, we can calculate the RMS value for either half cycle or full cycle. Why? Because RMS value formula is square root of mean of root mean square root of means of squares of instantaneous values over a cycle. So that I equals to formula, the formula will be I equals to square root of 1 by t integral 0 to t I square into dt. So squaring on both side, I square equals to 1 by 2 pi integral 0 to, here t equals to, here I am going to calculate the RMS value for entire cycle. So entire cycle t is nothing but here 2 pi. T is nothing but 2 pi. So 1 by 2 pi integral 0 to 2 pi Im sin omega t square into d omega t. So here constant terms Im square by 2 pi of integral 0 to 2 pi 1 minus sin square theta can be written as 1 minus cos 2 theta by 2. In this way we have written 1 minus cos 2 omega t by 2 into d omega t. Next up Im square by 2 into 2 4 pi of integral 0 to 2 pi 1 d omega t minus integral 0 to 2 pi cos 2 omega t into d omega t. Next up Im square by 4 pi integral 0 to 2 pi 1 into d, same step 1 into d omega t minus 0 0 to 2 pi cos 2 omega t into d omega t. Here we can apply the limits. Im square by 4 pi into integral 1 d omega t is nothing but omega t. Here omega t we are applying the limits 2 pi minus 0 minus integral cos 2 theta. Integral cos 2 theta will be sin 2 theta by 2. Then we can apply the limits. Sin 2 theta by 2. Sin 2 into 2, 4 pi. Sin 4 pi minus sin 0. So this value will be 0. Sin n pi value 0. We can place instead of n any value. Sin 0, sin 2 pi, 1 pi, sin 3 pi, sin 4 pi, sin pi, 5 pi, any value. Sin n pi value will be 0, so that this value will become, this term will become going to 0. So Im square by 4 pi of 2 pi minus 0. So Im square by 4 pi into 2 pi, pi will get cancelled 2 times. It will get cancelled 2 times. So Im square by 4 pi into 2 pi. So finally Im square by 2. So IRMS square equals to Im square by 2. So IRMS equals to Im by root 2. Im by 1 by root 2 value 0.1 by root 2 value 0.707 Im. So in this way RMS value of sinusoidal signal will be obtained. So average value of sinusoidal signal is 0.636 Im and RMS value of sinusoidal signal is 0.707 Im. Next, we can calculate the form factor. As we discussed in previous class, form factor equals to ratio of RMS value to average value. So, already we have obtained RMS value equals to 0.707 Im divided by 0.637 Im. So, finally, form factor equals to 1.11 for sinusoidal signal. In this way, similarly, we can also calculate peak factor. Peak factor definition is the ratio of maximum value to RMS value. The maximum value is taken as for a given sinusoidal signal Im divided by RMS value is just now obtained 0.707 Im. So finally peak factor equals to 1.414 sinusoidal signal. So for sinusoidal signal, form factor equals to 1.11 and peak factor equals to 1.414. So in this way, we can calculate the average value, RMS value and peak factor and form factor of given sinusoidal signal. Now let us exercise some problems on RMS and average values for given different waveforms. Where we can calculate the average and RMS value for the given signal. Calculate the RMS value, average value, form factor, peak factor for a periodic current having following values for equal time intervals, changing suddenly from one value to next as 0, 2, 4, 6, 8, 10, 8, 6, 4, 2, 0, -2, -4, -6, -8, -10, -8 and infinity. Like that, this wave is varying. So the given waveform is represented as shown in below figure. From 0 to 2, waveform is varying from 0 to 2, then 2 to 4, then 4 to 6, then 4 to 6, then 6 to 8. Like that, the waveform is varying, then decreasing from 10 to 8, 8 to 6, 6 to 4, 4 to 2 and 0. And negative values from 0 to -2, -4, -6, -8, like that the wave is continuing like this. So for this type of waveforms we can calculate average value by using graphical method. So average value of given signal, average value of current for a given signal equals to, so as we know that average value equals to area under one alternation. It is symmetric signal, the wave is repeating, the waveform is repeating, so that for a given symmetric signal average value should be calculated for half cycle only. So that average value equals to area under one alternation divided by base length. So these are the 0 plus 2 plus 4 plus 6 plus, these are the mid ordinates of the given waveform. So 0 plus 2 plus 4 plus 6 plus 8 plus here positive half cycle divided by how many terms are there, how many stepped signals are there, total 10. So divided by 10 equals to 5 amperes. For given signal, average value equals to 5 amperes. Similarly, RMS value of current. RMS value of current is nothing but root mean of squares of instantaneous values. So square root of means of squares of instantaneous values. So in this way, RMS value will be obtained by using graphical method. So RMS value equals to 5.83 amperes, average value equals to 5 amperes. Let's move on next problem. Calculate the average and effective values. Effective value is nothing but RMS value. Another name of RMS value is effective value. So calculate the average and active value of effective value of sawtooth waveform for a given signal. So the voltage completes the cycle by falling back to zero instantaneously after regular interval of time. So first we should identify the whether it is a symmetric signal or unsymmetric signal. If it is symmetric signal, we should calculate the average value for half cycle only. If it is unsymmetric signal, average value should be calculated for full cycle. Similarly, RMS value also, if it is symmetric signal, we can calculate either half cycle or full cycle. Both same value will be obtained. If it is unsymmetric signal, RMS value should be calculated for entire cycle only. So that for first we should calculate that this is a sawtooth waveform from 0 to first we should identify the complete cycle. One complete cycle duration is 2 seconds from 0 to 2. Here next cycle is coming. Here next cycle is coming. So each cycle takes 2 seconds only. So here like this number of infinite cycles are occurring. So that in this waveform from 0 to 2, 0 to 2, exponentially the wave is voltage is increasing. So voltage is increasing. So for this type of curve, we should calculate the slope. Slope equals to y2 minus y1 by x2 minus x1 of t. So 200 minus 0 by 2 equals to 100. 100 into t. The for the 100 t for 0 less than t less than 2. 100 t is instantaneous value of voltage. Small v equals to 100 t for 0 less than t less than 2. Here we can calculate. Next we can calculate the average value equals to area under the curve divided by base length of the curve. Base length equals to 0 to 2 only. So integral 0 to 2 100 t into dt divided by 2. So 1 by 2 into 100 into integral t by 2, that means t square by 2 limits 0 to 2. So 50 into 2 100 volts. So average value equals to 100 volts. Similarly, RMS value of given signal equals to root mean square. So square root of integral 0 to 2 100 t whole square into dt divided by base length 2. So square root of 1 by 2 into 100 square into t cube by 3 limits 0 to t. So that next we can simplify this equation. Square root of 5000 square into divided by 2 means 5000 into 8 by 3 t cube. Oh, 8 minus 0 by 3. So finally RMS value equals to 150 minus 47 volts. So in this way average value as well as RMS value will be calculated. For any type of signal we can calculate average and RMS values. Similarly, next problem, let's move on next problem. Calculate the average value, RMS value and form factor of output of a rectifier output. For a given sinusoidal signal, half a rectifier output equals to Im sin omega t. Half a rectifier output is one which rectifies the half cycle only. Half cycle of the input applied and its output waveform is shown in below figure. So half a rectifier, it will conduct only positive half cycle only. During the negative half cycle diode, it will not conduct. So first similarly, for the given signal, first we should identify the complete one cycle where cycle is repeating. Where is the cycle repeating? From one complete cycle equals to 0 to pi. One complete cycle equals to 0 to pi. 0 to 2 pi, 0 to 2 pi. Here 2 pi only, next cycle will be repeated. Next cycle base length is from 2 to 4 pi. Then here infinite number of cycles are occurring. So in this way average value equals to the for a given signal is unsymmetric signal. So we should calculate the average value for full cycle only. Full cycle only. Average value equals to area under the one cycle divided by base length. So here integral 0 to pi. 0 to pi, the wave is varying sinusoidally. So 0 to pi I into d omega t or d theta plus integral pi to 2 pi. The wave will be flat, zero value. So 0 into d theta divided by base length, total base length, one cycle base length 2 pi. So 1 by 2 pi into integral, this term will be 0. So 1 by 2 pi into integral 0 to pi I d theta. So 1 by 2 pi, I is nothing but I am sin omega t, sinusoidally varying from 0 to pi. I am sin theta into d theta. So I am by constant term, I am by 2 pi into integral sin theta minus cos theta. Then minus cos theta, then we can apply the limits. So I am by 2 pi into 2, I am by pi. So average value equals to 0.318, maximum value 0.318 into maximum value of current. Similarly, RMS value equals to square root of area under the one cycle divided by base length. Similarly, square root of 0 to pi I square into d theta plus pi to 2 pi 0 square into d theta divided by base length 2 pi. So next up 0 to square root of 1 by 2 pi. Similarly, same this term will be 0. So 1 by 2 pi integral 0 to pi I m square sin square theta into d theta. I m square by 2 pi integral 0 to pi sin square theta can be written as 1 minus cos 2 theta by 2 into d theta. So square root of I m square by 2 into 2 4 pi of integral 1 into d theta minus sin integral cos 2 theta will be written as sin 2 theta by 2, then apply the limits. So similarly I m square by 4 pi into pi theta means you can apply the limits pi minus 0, this term will be 0, sin 2 pi minus 0, sin 2 pi value 0, sin pi value 0, so this term will be 0. So I m square by square root of I m square by 4 pi into pi. So finally I m by 2. So RMS value equals to 0.5 times of maximum value. For the given signal, form factor equals to RMS value by average value. Form factor equals to 0.5 Im divided by average value equals to 0.318 Im. So finally for this problem, form factor equals to 1.5723. So in this way we can calculate the for different signals average and RMS values as well as form factors, peak factors can be calculated. Thank you.